Okay, class, let's begin from here again. With EVT in the background, we now want to actually embark on this question. Example 33. To show that this function has an absolute maximum and minimum, we will then have to show that this function is continuous on a closed interval. So to start with, this function, by its definition on the left and on the right, you say that this function f, right, this f is definitely, right, is continuous on 0 to 2 and on -2 to 0 since x minus 2 square and x plus 2 are polynomials. So the only point of contention will be actually the dividing point. The point in this case is 0. So you need to check, no? You need to check, no? To check f is also a continuous on x. X equals to 0. Now, how do you check the function is continuous at a point? How do you check? Yeah. So now you check the left limit. 0 minus, and I told you a few times, that we prefer that you show more workings like this. For 0 minus, right, the function to use is actually x plus 2 squared. And this gives me 4. Then next is limit x tends towards 0 plus fx. This gives you limit x tends towards 0 plus. Okay, for 0 plus, right, is x minus 2 squared. And again is 4. And then thirdly, f of 0. Okay, maybe I should say this thing first. Okay, so by 1 and 2, limit x goes with 0 of fx is equals to 4. Okay. Then after that, right? After that, we go find we go find f0. Wait, don't kill me, I'm going to relabel this. I think I'm going to relabel this 1a, and 1b. And then what's the difference, right? Because 1a and 1b together is 1, I know. Our mind can only do 3. We can remember 3 things or do 3 things. Okay, f0. Right. f0, right? For f0, which function do you use? The x minus 2 square. Okay, x minus 2 square. So this goes to 4. And number 3, you say that f0 is equals to limit x tends to 0 of fx equals to 4. So by 1, 2, and 3, f is, yeah.
Can we like cut down on the log?
Potentially, if you have a way to make it more concise and precise, sure. And without losing the meaning.
I just see like you just go to step 3 and then like it's step 2 to step 3, right?
Maybe.
Yeah, actually, though,
Like you can just put limit f(x) equals to f(0), which equals to
Yeah, potentially, yes.
wait, is that allowed?
I prefer like this, no?
Okay.
But it's so much more. I mean, it really doesn't matter. It's like if you're gonna write, then what's the point? You just have to write it anyways. It doesn't matter if you write this one line of code.
If you ask me whether or not I can write EBT in the exams, technically, usually it's quite okay.
It's quite.
I mean, EBT and IBT is like the teachers don't understand it. It's actually very clear, but you can be very clear.
Yeah.
So we need to say by like what theorem?
Yep. Yeah. Okay. So to show that a function has absolute max and minimum, right? You just have to show that it is continuous on a closed interval. Okay. Then followed by this, right? Followed by this, the question asks for the absolute max and minimum. You will realize that in the AP exams, they actually require you to do this, no? To find absolute max and minimum, you must actually do two things, no? Values of f at critical points and secondly, right, values of f at endpoints. So the AP, if you read the AP exam marking scheme, right, they will actually do these things, and sometimes they will even draw a table in the marking scheme, no, to do this, no. Okay, they will even draw a table to show you the values of the function at the critical points and also at the endpoints. Okay. So in this function, you look back, right? Okay, let's do the endpoints first. Endpoints are the easiest. Where are the endpoints? The endpoints are f0, sorry, f of minus 2 and f of 2. So let's do the endpoints first. F of minus 2.
0.
Is it 0? Then x is minus 2, right? Right. So it's actually minus 2. Then f of 2. So you can do this now. You can potentially do this now. Okay.
Are you supposed to be looking at in case you get like one?
What do you mean if I get in between?
So I mean like if you isn't the x supposed to be exponential, so in case you get like x equals -1 or something, you can use to put it in between.
It doesn't matter. The listing up doesn't matter really. It doesn't matter. Okay. So then next thing is we want to look for the critical points. What are critical points? Critical points are points where the gradient is 0 or undefined. So for this function, like between 0 and 2 and between -2 to 0, how are you going to obtain the critical points? No? So one way is for you to roughly do a sketch of the graph first to see what is going on first. It helps. No? This 2 and -2. Okay, between -2 and 2, if you draw the graph, right, the graph should look something like this. And the other side is like that. So judging from this graph, there's actually a back point. This is the back point. A sharp turn is called a cuffs. Cuffs. Okay. So this sharp corner are potential points, which we call critical points. And at this point, indeed, it is not differentiable because it is a sharp corner. So technically, you have to first and foremost demonstrate that at x to 0, it is not differentiable, right? And that is actually the subject of the technically subject of the next chapter. But let's talk about it briefly. Let's talk about it briefly. So actually, we now want to state a statement of function f has a critical point at x equals 0 since f prime 0 is undefined. And the other thing is, to look for the other critical points, you ought to differentiate the function and equate to 0 the gradient and see if there are actually other x's. And in this case, right, the potential points where the gradient is 0 are the point -2 and 2. But these two points cannot be deemed as critical points because to be critical points, right, it must also be interior points. So between -2 and 2, right, the -2 and 2 being the endpoints are not considered as critical points at all. Okay. So for the reason, right, we will discard away -2 and 2 because they cannot be considered as critical points. They are what is called endpoints. You know what I'm saying? So technically, you ought to differentiate and show that the only 2 points where the gradients are 0 are at -2 and 2. But as I told you, endpoints are not deemed as critical points, so they are discarded away. Hence, the only critical point that we have is f prime 0. At x equals 0. So now the next thing is we want to calculate this number. At this critical point, f0 is how much? f0. Okay, which function do we use? We use the x minus 2. So it become 0 minus 2 square, which is 4. So 0, it is 4. So from the values of f at critical points and endpoints, the absolute mean equals 0 and absolute max is equals to 4. Yes.
Is it okay to present it? Is it okay to present it in the format where you write either like min or max, then there's like the bracket thing, then you put f whatever inside?
Like that. I don't know. Is it what I say?
There's a curly bracket, and then you put all the values. And then you say like the mean of all of these equals.
The mean of this,
like f
like that is equals to 0, like that. The mean of a set of numbers and the okay. I understand what I'm talking about, but this is not what AP exam does. They do that the way. They will always put a table, and then from the table they actually visually judge from the table. They don't use notation. I understand what I'm talking about, and I think that if you write down potentially, I think they understand you. Just that if you are taking an AP exam, you want to be exam smart, You want to just conform, Just examination is about conforming to the to the requirement. Okay. if you're wondering, why is there such a large space left there? No? Actually, the expectation was for student to prove that by calculation, no, that f prime 0 is undefined. But to do this, it's not easy, no, because to find f prime 0 by definition is like that, you know. By definition, it's like that.
You can do like plus and minus,
You should do this because the proper way.
right? You should do it like plus and minus, right?
Yeah, after that, go to do the left derivative and the right derivative. Yeah, she's right. Aditi says from here, right? From here, you will branch into two. You will branch into the left derivative and then the right derivative.
So we must do both sides.
Technically, yes.
Can I do?
That's why for this question, because it's in chapter 1, we want to take it easy. We judge it visually because of the sharp corner, right? And the curves, and therefore we know it will not be differentiable then.
So does that mean that just draw the goal?
Okay. In the exam, how would you do it, right? You got to look at the question and you have to assign some guts feel. You know, what do you think the examiner wants you? The problem about this AP exam is they don't tell you the score for each part of the question. They don't. So you got to assign judgment. But I think potentially they will have an earlier part to scaffold you and tell you to prove that it is not differentiable then. And then they owe you marks for that portion. They will scaffold you. Okay. Okay. Let's press on. So now there's a remark here, no? If you want the point instead, right? You're supposed to write down the coordinates, no? Okay, so the answer to this is no, no? The answer to this is no. You can draw many graphs to show that it is no. For example, right? For example, you can draw a graph that is like this. Okay, maybe like that. This is like tangent graph. It is continuous on an open interval. It has no absolute mean nor max because it goes on forever. Let me draw some nice now. Okay. Or you could have a graph that is like this, no? You can have an absolute mean but without absolute max. This graph is like the second graph here. Okay. So this function, they do not have absolute mean nor absolute max because they are continuous on the open interval. However, be very careful, no? It is potentially possible that if a function is continuous on the open interval, that it can still have absolute mean and absolute max on it. Yeah. Yeah. So the openness is actually doesn't eliminate the possibility that you have absolute mean and absolute max. Like this one. Right. This function has both. It has this one has absolute mean and what I'm trying to tell you here is while EVT says must be closed interval and EVT says if it's continuous on a closed interval it guarantees you in the event that you don't have the open interval, EVT says it's a closed interval, right? In the event that you do not have continuity on a closed interval, it is still possible that you might have still the absolute mean and absolute maximum, right?
I mean, isn't the EVT like if it has a closed interval, then like you will have absolute mean of max, but like it doesn't necessarily say that if it is not closed interval, it doesn't have
say the right word. This is so the quantity on a closed interval is what kind of condition? Is a sufficient condition.
The statement itself is true, but like no, it's converse. The converse of it is
So the continuity on a closed interval actually is a sufficient condition. Let me know. Not a necessary condition. Okay. The continuity on the closed level in the EBT is a sufficient condition, right? Not necessary.
Wait, but if it's open and like it's like that graph, it still doesn't have a minimum or a maximum.
Which one?
Like the last graph,
It has
it does.
absolute minimum, absolute maximum.
Okay, that's good.
Yeah.
But so you just don't count the end point.
Yeah, because in this diagram, right, it is quite clear that the absolute mean and absolute max they exist. There's such a point that attain the absolute mean. There's such a point that attain the absolute maximum. Okay. You want to note this thing, no? Okay. So when this thing happens, okay, you got to do a lot more work to look for the absolute mean or maximum. Okay. Quick check exercise. Okay, let's do a quick check exercise. Okay, let's have the boy right at the corner. What three conditions are satisfied?
Just see. FC is defined. Limit x.
Limit
Approaching C.
limit
exists.
x tends towards C exists. Next one. FC is defined. Then thirdly, limit you know what I mean? So of course the concept of continuity is quite trivial. Just that you do it by calculation, you need a bit of effort. The next question. F and G are continuous. Find G of 2. Okay, let's hear from the boy next. Lead us. Question 2. Okay, of course you meant to say that from here, right?
The answers are usually right now.
You will say that I can write this as sum of the two limits because both limits exist. There's a 4 here. I can see that you're very happy to be in school. Okay, actually I can offer you the option of just moving yourself to the back, you know, so that the two boys can entertain you conveniently. Yeah. So she's called the, you know, there's this Chinese phrase called 校花, you know, 校花means flower of the school. I guess maybe we start with flower of the class first, okay? Flower of the class, okay. Okay, so in your working for A, you want to do this thing, no? Right, you do this thing. And for this one, right, for this one, this is obviously g of 2. And then you would have found g of 2 from here. So you say g of 2 is 4, is it? You say 4? The boy behind says 4, is it?
I said 2.
3. 3, yeah, right. 3. So it's 3. Okay, for the next question, the third boy at the back. Let's leave us, yeah. How do you do this question? Say. Are you saying this? Okay. And then the limit for the function f is, because they are continuous, this is just f of 3. And then given a limit. I tested myself this morning before coming to school. It's negative. Yeah. For COVID, I tested.
It's okay, even if you're positive, you can say
Huh?
even if you're positive, you can
I wouldn't dare. I'll lose my job. I will go and see a doctor later on in the afternoon to be sure that things are alright. Okay. Yeah, you want to go to toilet again, then go to toilet. Okay, let's do this question again. Let's do this question. For what value of x, if any, is a function discontinuous? Okay, how do you go about doing this now? One way of doing this thing is, you want to actually factorize the denominator. And at the point, at point 1 and at the point 4, these are the potential candidates that the function is discontinuous. Yeah. Because at this point, right, these are the potential candidates. At this point, right, the denominator will be 0. 0. Alright. And therefore the function will be undefined at this point. So based on this, right, the values of x, they are going to be 1, okay, and 4. However, the question didn't ask for it, no? Let me ask you, if I ask to discuss the type of discontinuity, let's hear from the next boy. Let's hear from. Okay, never mind. Yeah, focusing. When you, if I ask you, no, the type of discontinuity, what do you think? Which one is removable? Okay, let's pause for a moment and let's delve on number 4, everybody. This function has two values of x, which are where the function is discontinuous. So the question is, what kind of discontinuity are these? Let's hear from Wen Yu. So what I can do is, one possibility is you more or less sketch a graph. The other possibility is you find the limit, the limit, the wherever you just find a limit at x goes towards 1 and at x goes towards 4. And you will find that in the case of x going towards 1, this one, right? This one, the limit is either infinity or negative infinity. Right? Two sides. On the other hand, this limit is actually finite. Yeah? And because the limit is finite, which means at x equals 4, the graph potentially is this nature. And because of this, right? Because of this, you therefore know that at x equals 4, right? It has a removal. Yeah. When the limit exists, right? When the limit exists and not infinite, right? This tend to be, I think it doesn't tend to be infinity, either plus or minus on one side and the other side. So in that sense, therefore, at 4, it is actually a removable. At 1, it's actually a infinite discontinuity. If you have a GDC and you draw the graph, you find that at x equals 4, it is what you see here. And at x equals to 1, it's actually a vertical asymptote.
We always say that, like, as long as we can make the denominator 0, then it's discontinuous at that point.
Not just that, because there are cases where your fx, for example, right, is ln of x minus 1. There's no denominator, but there's actually a vertical asymptote. In a minute. I beg pardon? Yeah, the denominator are the main culprits. You're right, Jethro, you're right. The denominators are the main culprits. Yeah, they will be discontinuous. Okay, let's go at number 5. At number 5, let you try. Everybody try number 5. Is Christopher in this class? Oh yeah, you texted me. So you finish all. You text me. Are you Chris? Are you the Chris who texted me? You texted me. So you finish the whole tutorial already. You finish the whole tutorial already. No. Okay. For number 5, right?
The limit is finite, so it's discontinuous. It's a removable discontinuity.
Yeah. When there's a limit.
But it's a limit like that.
Okay. Okay, for this question, it might be easier for you to write down as a table the function and its value. You want to write down -2 is 3, -1 is -1, 0 is -4, 1 is 1, 2 is 5. If you write this way, you can see very clearly that there's a change of sign here and there's a change of sign here. So that tells you that you have a root between -2 and -1, and a root between 0 and, okay, in this case 0 and 2 line. Actually 0, 1 will do. Right, so these are the two intervals for which the function f has, if I could change the word, right, has at least one root 9. It guarantees you at least one. It can be more. We do not know. Right?
Yes.
Okay. So with this, right, we will now there's another interval, -1 and 1. Yeah, I mixed up this one from class. I overlooked this one. Yeah, between -1 and 1, yeah, there's also a change of sign. So I should also include this interval. I was trying to narrow down to a shorter interval. I overlooked part C. So this question is a trick question, you know. I was just looking for a very specific interval, but actually -1 and 1 is also possible, because between -1 and 1, right, there's actually a change in sign. So therefore the answer is 3 yeses. Okay. You got questions to raise before we embark onto the tutorial? It's not consecutive, it's not consecutive. Yes, Jetro?
Then technically you're not getting negative number multiplied, but then
Negative to 2, right? Negative 2 to 2, right?
yeah, that doesn't guarantee it because if you break it down further, it does show that.
Yeah. That means yes, it'll be a yes.
Don't break it down further, I don't show it.
No, if they say minus 2 to 2, right? Your answer is yes.
But it doesn't guarantee you don't break it down any further. Like you don't have to provide the value.
That becomes a trick question, though. Because you calculate f minus 2 and f of 2, it seems don't have, right? You have to dig deep into it. Yes, Jetro, you have to be very careful. Yeah, it can be trick. It can be trick. Yes, you're right. In the first question, right? In the first question, if I ask to find the limit of this function, it is simply 1 square
Okay. 2 divided by 2.
I was just kidding. Sorry. You want to present it nicely. For this one, instead of writing the answer immediately, is 0. Alright. For the third question, so in presentation, you want to actually show that you actually plug it in, you know. And then right, in this case right, these two will go off, right? This will go off. And we all know that sine of pi over 2 is 1, and this is 0. So the answer is therefore just 2. For the next question, right? Okay. For this question, we want to actually, in this question, if you try putting 3 to the numerator and 3 to the denominator, it won't work, you know. You want to perform a factorization. And this gives you, upon cancellation, right? Limit allow me to just go around the room to see what I've done for tutorial. Okay. How about you? Did you do a tutorial? Okay. Okay, good. Halfway yet? What you did? You did come here and there. Oh, Jetro just started.
Hey, you didn't say go to the toilet, right? Wait, no, shit. Wrong lah. That's why I ambiguous. It could be anything. Wrong lah. Wrong lah. Oi.
Okay, let's pause for a moment and say this again. Class.
It's very sad that you didn't ask it. You did everything.
Yeah, some Chinese know that.
When I see the Chinese text 27, I like.
Some question can tell
I don't want to show what.
Okay. So my guess is I don't have to do every question. Let me just do selectively. Like number four, the use of the squeeze theorem. You want to be very mindful, no? In using the squeeze theorem, you want to start off by saying this, no? Establishing the inequality that cosine of this thing is between 1 and minus 1. Right? Then you say that this is like that. Okay, class, squeeze theorem is quite easy, but I want to caution you, class, the presentation is where people will lose marks. You want to look up, squeeze theorem, be very careful, You want to make sure you present it rightly. So the first step is you establish the inequality, and number two, you want to find a limit when x goes to 0 of the left function and limit Okay. Therefore, by the squeeze theorem, limit Yep. A question is raised, A question is raised. A question is raised, A class. Does it matter what is inside here, You're trying to say? Yeah. Does it matter is long x or long anything? Doesn't matter, right? It's true. Yeah. This thing inside is not the important stuff. Actually, anything will work. You're right. Okay.
Good job.
For number five, class. Okay, I guess people are restless. The boy who is scratching yourself.
What?
I cannot remember all your names. Can you march forward and do for us 5B on the board? Come. 5b. 5b here. Can you do 5b for us on the board? Can I use repeater or no? No. Can you, Jethro, can you nudge the cupboard? Nudge. No, not asking you. The boy in class. Okay. Wait, let's invite Tingwei, show us. I want to carry out an experiment to show you that even when Tingwei doses in and out of the sleep, she knows her work. That's why I let her alone, you know.
Yeah, right. As long as it doesn't actually fall asleep.
Okay, this is what she's doing, you know.
But that change the volume. Then you can change the whole value, right? Wait, do you use time?
I don't care.
What is an X? What is
It's okay actually, it's okay.
You can't use that. It's an X.
Okay, she's right. For the case of 5C, right? Let's hear from Ethan. What is that one essential step? What do you do with 5C? You don't have to, no? Yeah, your method works. I will use a method, but it's okay. You could have done it without, but it's okay. I'm going to use your method.
How you do it without?
Okay, if I do it without, right, I will just simply write this as sine x times in the middle. I could have done it this way. I could have done it this way. But your method is okay, you know. Yes, I make mistake. Just like oops.
Okay. Why did I go to that?
Yeah, thank you. Okay, Tingwei, I saw your mischief. I'm not sure if you have done number 6. For question 6, right? You're given a piecewise function. Again, class, I want to stress, you know, that to do a question at number 6, I prefer that you do not write down the answer as 16 right away. No, I prefer not. No, I prefer that you write limit x goes towards 2 minus 2 minus, and then I will put 8x. No, I will do this first. I'll quickly do this first, and I get 8 and 2. And of course, you say, Mr. Lim, too much writing. It's true, right? For beginners, we want to be goody. No? Alright. Likewise, for the part 2, you want to write it as like this, no? Okay, this gives you limit x goes towards 2 plus of more than 2, right, is ax square. So that gives you a and 2 square, that gives you 4a. Now, then for part 3, if you immediately say a equals to 4, I want to assure you something, no? You will get full credit, no? You won't. Why? Because we want you to show that because this limit exists, you will say, so the left limit at x goes to 2 minus of fx. So the whole idea here is, we want you to write down your reasoning, your reasoning, and this implies that 16 is equals to 4a. And of course, in exam, you won't squeeze things like what I'm doing here, because I'm not doing on full scan, you see. You should be doing nicely on full scan and writing this as 3 different lines. So now, if I ask this question, is function continuous at x equals to 2? What do you do to check? Okay, the 3 steps, right? First, you got to calculate f of 2. Based on the definition of function, is equals to 8. So it's equals to 16. Number 2, you take the limit as x goes towards 2 of fx. We also know from part 1 is also 16. This is from part 1. And then there's a step 3. You need to say step 3. Step 3, right? You got to say f of 2 then you got to say therefore, here I say therefore by 1 3 f is continuous at x equals to 2.
You need to do the numbering.
Yeah, Yu Tong says, Mr. Lim, stop the numbering. It's annoying. She's saying this now. If you insist, sure. You can say from the above. True. Yeah. I prefer to number them because it becomes very systematic. Right. If you prefer not to say 1, 2, and 3, you can just say from the above. Right? Okay. For the part 5, right? Let me ask you this thing again. What is this actually? Right. This one is actually I'm going around the room to see for those that have done it. Let me see your working. For those that have done it, let's take a look. Not bad, you know your work. Good. Let's see Ting Wei's. It's still in production. Let's see Yu Tong's. 还没做. Let's see Christopher. 你做了没有 Have you done? Oh, let's take a look. I did actually. You work it up. Can you work it up now? Yeah, work it up. Right. For those that haven't tried, you want to do it now.
I'm trying my best.
Okay. Yeah, you know your work. Let me see your that part. The checking that f prime 2. So you calculated the left and the right. Yeah.
Oh, so you have to do.
Did you do? For those who haven't done this, class, I want you to take that 3 minutes, class, to actually do this part 5. It's worth it, no? You should do it. Let me erase off and then make it clearer what I'm talking about, no? Okay. I want to disconnect first. Okay, class, the 3 minutes you spend now doing this is worth it, no? Because you want to be very sure the tediousness in doing this. You want to do it at least once now. Let me check others. You must do the left and right. This is right and this is left. This is left. Okay. Oh, okay. You eating like the plantation nicely, huh? What did you say?
But I think it works.
It's more or less there, you're right, more or less there. Okay, RPT, you got infinite limits, is it for the left or right? Okay, let me correct because when we has a different answer, okay, let's do it together again. Do it together. Let's do this together. Okay, let's do the left first. Okay, let's do the left first. Limit x tends towards 2 minus.
Everything is here.
On the left of 2, we use 8x. Okay, this will be limit.
Oh, Mr. Lim, I think I found my mistake.
You made a mistake, is it?
I forgot the minus 16.
Okay.
Oh my god, coming out.
It's 16 and 16.
Is the left limit 8?
Yeah.
Okay.
The right is not 8. I got 16 for the right.
The right is 16, is it? Let me check. Okay, for the right side, we use ax squared. A is 4, right? 4x squared minus 16. So this gives you
4 times x plus 2.
take up 4.
Is your age from the previous question?
Okay. So because okay, if I label this as 1 and 2, right? Then I say that it is equal to D and E since 1 not equals to actually I will spell this whole thing and this whole thing in my working line. No, if I do it. Okay. That means the left, this is called the left derivative, and this is called the right derivative.
Can you just like differentiate the piecewise function?
Okay, let's do it again. So it's a good question raised now. There's a question that's raised this way now. Say from here, right? From here, right? Can we not just differentiate, Can we not just differentiate and say that let me erase all this to make space. The question asked is, can I do this? This becomes 8 and this becomes 8x, right? Because a is 4, see? Now if you differentiate like this, right, you can at best say this only, no? At the point 2 is questionable, because that's the dividing point. So from this line to this line, it is legit. Now I want, since we talk about this, I want to tell this thing though. Some people told me, some people say, can I not do this? Can I do this to judge if f prime 2 exists? You see, earlier on, we were interested in this, right? We were interested in checking whether or not the derivative at x equals 2 exists. And I told you to check this one, right? To check this one is to check this, no?
The question is like asking whether it exists or not, and the answer is that it doesn't exist. So, like, if you know that approaching from the left and approaching from the right is already different, even though you don't know what like f prime 2 is, you can already know that it doesn't exist by differentiating the pieces.
Okay, point taken. He is trying out to me this thing, which is what a lot of people do. He says we do not know exactly what is it at x equals to 2, but by judging from here, you can guess that coming from the left and coming to the right, the values are different. So it gives you a hunch that at f prime 2 therefore does not exist, right? But I told him this is an unofficial way of checking on them. This is not acceptable in working for AP exam. If you are ever asked to check if this exists, right, you really have to check from the first principle, like that. You really have to go through this process. You cannot just take a shortcut like what you're trying to say. It gives you an indication, but that kind of working is not acceptable. So class, I'm trying to tell you, in the long and short, trying to check this thing by looking at this one, I want to tell something. It's not a correct thing to do. It's different, different. Okay, so don't do this. So whenever you're asked to find to check for derivative, right, you really have to go back to this statement. It is something you have to note. See, over here, right, it is inclusiveness, but when I differentiated, you must realize that it becomes exclusive of 2. You must remember that, because at the point 2, it becomes questionable. You have to do a bit more work to judge. And how do you do it? You really have to go through this hassle. Okay. Okay, so with this, someone has tried the intermediate question. I was told. Some of you, like, can Kailash try this question? So Kailash, you get answer?
Yes.
Okay, let's have Kailash to present 7 part 1 because he's waiting to present. Okay, Christopher and I communicated all weekend, so I know about his fault. This is a question raised.
So you can do those. Like, what's the limit of I guess this is the better thing to use when you want to
Do something for.
Suffering noise. Okay, let's go.
Kalash, the writing, how many people you from back?
I think it's too small.
What's that again?
Let's go.
It's alright. I didn't do. Okay. Too busy with other thing now. Go there. Let's go there.
Yeah.
Jing Wei, may I take a look at your work? She did.
She actually asked me for money.
Oh.
Where did X to the 4 come from?
Okay,
Where did X to the 4 just magically appear from?
let's see. X power 4. Where does X power 4 come from? Kalash.
Where did X to the 4 come from?
Oh, you went to times by he went to times. He's saying okay.
I forgot to show the
Yeah, you gotta show a bit more. Show a bit more. He went to times.
I just realized I forgot.
It times both numerator and denominator.
I'm confused.
No, the denominator doesn't get.
Yeah, I did. Minus. I forgot to show that working because I wrote it here, but then I forgot to write it down here.
Oh. You don't really need to do that now. If it works, it works.
Yeah, that's exactly my cash quiz work. If it works, it works. Yes, AP exam moment.
You can directly like get X squared plus A squared without even okay, just look at the thing. Oh my god. I really don't think you had to do that. I really don't think you had to do that.
Oh, it's 19 and 4.
No. Origin don't have origin. Yeah, then okay. Then become x4, a4. Yeah, x4, a4. Okay. Can. Okay, allow me to. Okay. I saw in one working that with this line, right? With this line, right? You are able to get a equals to 6.
It can also be 0.
It can't be 0 because it's on the denominator.
Yeah, but you need to like.
I think it can't be 0. If it's 0, then how do you get?
She's right. Maybe put a remark. Yeah, I didn't say that. Okay. So he has presented a very clever way. What he did was he multiplied by x plus a. Kailash in writing is going to put brackets. So he has reduced into this easier form, and then just bring him up to here.
OMG.
And then. Okay. A lot of others like him, and they did it by factorizing the numerator. No? Yeah, they did by you can factorize the numerator as well. It's also.
Because if I do that, I can just do the minus of that.